Hi everyone, welcome back to my channel. This is Mr. H, and in this video, you will learn about asymptotes of rational functions. So we're going to be covering here horizontal asymptotes, vertical asymptotes, and slant or oblique asymptotes. Alright, so let's take a look at some diagrams here. I'm showing you graph A. So in this graph, you can see vertical asymptotes, literally vertical lines, right? So here, each vertical asymptote has its own equation. You can think of it as equation of a vertical line, which is x equals something. For example, this vertical asymptote here, the equation of that vertical asymptote would be x equals -2. Right? And for this vertical asymptote here, that is x equals 1, and vertical asymptote here, far right, x equals 5. Also, on this diagram, we have horizontal asymptote is here. Not too obvious. So same as the x-axis. And if you can recall any equation of horizontal lines, so we'll have y equals something. All right, and in this diagram, since the horizontal asymptote is the x-axis, so you can say that the equation of that horizontal asymptote is y equals 0. All right, so let's take a look at graph B. All right, so graph B shows as the slant or oblique asymptote. You can recall the equation of line in the form of y equals mx plus b. That is an example of slant or oblique asymptote. All right, so to further understand, so we will be answering a few examples. And let's get straight to the very first one. For example 1, we're given this function here, rational function, and we are asked to find the vertical asymptote. So vertical asymptotes happen where the denominator of the given rational function, so this is the denominator, will be equal to 0, while the numerator is a non-zero expression, right? And the vertical asymptote actually represent the values of x where the function is undefined. All right, so with that concept, in order for us to find the vertical asymptote of a rational function, that means we will be setting the denominator equal to 0. All right, so usually what we do is we do factor the numerator and the denominator. After doing the factorization, that's when we equate the denominator to 0. All right, so let's take a look at the numerator first. All right, so as you can see, the numerator is x squared minus 4. This binomial can be factored into x plus 2 and x minus 2. While the denominator is a quadratic expression, and by looking at it, that quadratic expression can be factored as well. So -2, and this is +1. Therefore, the factors will be x plus 2 and x minus 1. After factorizing the numerator and the denominator, see if something can be canceled out. And for this example, it's so clear that x plus 2 from the numerator and from the denominator gets canceled out. So if this happens, all right, this is not considered, they are not considered asymptotes. We call it the holes or removable discontinuity. So that means that the given function, when it's graphed, there will be hole at this point. And what we need to do next is to set the denominator equal to 0. And that will be our vertical asymptote. Alright, so we take the denominator, which is x minus 1, equated to 0. Therefore, the vertical asymptote is x equals 1. That's the equation of the vertical asymptote. Alright, if you think that this example is easy, let me know by dropping a comment below. And don't forget to hit the like button. Alright, so let's move on to example number 2. For this question, we are asked to find the slant asymptote, which is also known as the oblique asymptote. Slant asymptotes occur when the degree of the numerator is exactly 1 more than the denominator. So we're going to be looking at the degree or the highest exponent of the numerator and the denominator. Okay, so for this example, if we look at the degree of the numerator here, so we can see that the degree is 3 for the numerator. That's the highest exponent. And in the denominator, the degree is 2. Alright, since the difference is 1, being the degree of the numerator is higher than the degree in the denominator, definitely for this one, there is a slant or oblique asymptote for this given rational function. Alright, and the question is, how do we find that? So what we need to do is, we need to perform division by using the long division method. Alright, so let's start dividing. So 3x cubed divided by x squared, it's gonna be 3x. Then 3x times x squared, that is 3x cubed. Then 3x times negative 3x is negative 9x squared. Next is 3x times positive 2, that is positive 6x. We need to subtract. Alright, so 3x cubed minus 3x cubed, that's going to be 0. Then we move on to the next pair, so 2x squared minus negative 9x squared is going to be 11x squared. Negative 27x minus 6x is negative 33x. And we bring down positive 22. And then we divide. Alright, so we take 11x squared divided by x squared. And that is positive 11. And then we multiply 11 and x squared, so that will be 11x squared. Then 11 times negative 3x is negative 33x. And last, 11 times positive 2, that is positive 22. And then we subtract. It just tells us that there is no remainder. So the division is done here. Now, how do we know the equation of the slant asymptote? So definitely you're going to be thinking about the equation of line, which is in the form of y equals mx plus b, which is the slope-intercept form. all right? So the quotient. So we're gonna take that and we write y equals to 3x plus 11. And this is the equation of the slant asymptote. So you just take whatever the quotient is, so just ignore the remainder. If ever that there is a remainder here, you don't take that. You only take the quotient. All right, so let's head on to our last question. All right, so for the third question, we need to find the equation of the horizontal asymptote of the given function h of x. So before we answer this question, let me tell you what horizontal asymptote is about. First, horizontal asymptotes describe the graph's behavior as x approaches infinity or as x approaches negative infinity. Also, in finding the equation of the horizontal asymptote, it actually depends on the degree of the numerator and the denominator. There are actually 3 cases here. All right, so case number 1, if the degree of the numerator is less than the degree of the denominator, then the horizontal asymptote will be y equals 0. Okay, so that's case number 1. All right, so for case number 2, if the degree of the numerator is equal to the degree of the denominator, in order to find the horizontal asymptote, we need to divide their leading coefficients. Leading coefficients are the numerical coefficients of the term that has the highest exponent. And for the last case, if the degree of the numerator is greater than the degree of the denominator, then there will be no horizontal asymptote. You can also check that maybe there is a slant asymptote or oblique asymptote. So that's a possibility. So we were given x to the power of 4 plus 3x squared minus 5 divided by 3x to the power of 4 minus x cubed plus 2x plus 11. And if we're going to take a look at the 3 cases here, we can see that it follows case number 2, in which the degree of the numerator, which is 4, is equal to the degree of the denominator. This is the leading coefficient. Numerical coefficient of this term is 1. All right? So that is 1 divided by, and for the denominator, the leading coefficient is 3. So 1 divided by 3, that's it. So 1 over 3 or 1/3. And to get the equation of the horizontal asymptote, then we just simply need to write y equals 1 over 3. So that is the equation of the horizontal asymptote of the given function. Alright guys, so that is all for this video. If you think that this video is insightful, give me a thumbs up. You can also share the video. And don't forget to subscribe to my YouTube channel. That is Math Hub by Mr. H. And once again, thank you very much for staying until the end of the video. And I will see you in the next one.